So as we discuss logarithms, there is a connection. Oh, we got this. Between logarithms and exponents. So let me define a couple of things for us here at the start so we can get going with this, okay? That little b that I have there stands for my base. So like if you have something like x squared, x is called your base. That's what we're going to be multiplying by, okay? X is going to be my exponent. And then y, for lack of a better term, we're going to call our solution or our answer. Because when we're forming these, when we're trying to find answers, that's basically what this y value ends up being most of the time. So when we're asked to rewrite a logarithmic equation, it can help us sometimes to figure out an answer if we're being asked for one. So here's how this works. Okay, right now it's in log form. It looks like this. If I want to get it like this, here's how it works. I'm always going to do my base value, so this little tiny subscript down here is going to be my base. Okay. The x value, this value, is my exponent. And then the big number next to my log is always going to be the quote-unquote answer. So if I asked you to solve this one to figure out what that x value is, you could. You could play around and figure out what to the 5th power is 32, which actually is 2, but we're not solving right now. Okay? We're just getting into the idea of rewriting these and what they look like. So as I go through, okay, again, the little tiny number is always my base. The value on the other side of the equals, okay, is always my x or my exponent. And the number next to my log is always the answer. And this is a true statement. 5 to the 0 power is 1. Anything to the 0 power is 1. And I make that work that way. And so I'll always end up with these true statements. But we're just getting the practice on rewriting them right now because, of course, we have to do it both directions. So base, exponent, answer. Okay. And if it's all numbers, the statement will always be true. If it's not, I didn't do it right. So like if I'd have written 10 to the 10 equals 1, well, 10 to the 10th power doesn't equal 1. That doesn't make any sense. So I go ahead and I work that one out. And so what do you think? What's this last one going to look like? There you go. 10 to the negative first equals 0.1. And if I wanted to check, I could even punch that into my calculator just to make sure. Because maybe I don't know since it's a decimal. I'm like, not sure about this one. 10 to the negative first. 0.1. There you go. Okay. I know I did it right. So just some ways for me to double check and kind of work those. So as I get a little further along, okay, like, okay, 1/2 base exponent answer. Now let's see, does that make sense? Let's think about it. Oh, 1/2 to the negative 1. We were talking about negative exponents a minute ago. It makes what's inside flip. If I flip to 1 over 2, it becomes 2 over 1. Okay, that makes sense. I can work with that. Okay, but what if they don't give me a value on the other side of equals? You know, what am I supposed to do then? Good thought, but not what we're looking for here. If they don't give me something on the equals side, okay, I'm just going to put the x like is normally there. And then if I'm asked to rewrite it that way, it's going to look weird, but we're going to do it. B, yes. Yes. And if I was actually asked to solve that, I could, because anything to the 0 power is 1. So if I was asked to find the answer, I could. Okay, I could figure out what the mystery value is going to be. The next one looks even weirder. Okay, let's check it out. Okay, so what would it be when I rewrite it? B to the x equals b. Okay, let me ask a question. What exponent's on this b over here when I don't see one? 1. So let's think about this for a minute. B to what power equals b to the first? Don't make this difficult. Yeah, the x value is 1 because b to the first would equal b to the first.
You just said it really confusing.
Yeah, you did.
B to the what?
B to the what power? b to the mystery power of x equals b to the first. We're just kind of solving a puzzle with what we're doing as far as those go. Okay? Oh, no, it isn't that bad. Okay. Evaluating them. Evaluate. What's evaluate mean? Okay, evaluate means solve. And no, unfortunately, I cannot just divide by 3. Here's what I got to figure out. There's some of these we might be able to, but for right now, here's how we're going to do it. Okay, remember how we set up above if there's nothing there? We kind of put an x over here. So here's basically what I'm asking when I do this. 3 to what power equals 81? And these will come out as nice values, so that's a good thing to know. Now, if I don't know that, I'm going to start playing with it a little bit. I don't know, 3 to the third power. Nope, too little. 3 to the fourth, I'm hearing. Okay. So my answer would be 4, because 3 to the fourth power equals 81. Okay, so there's this form that we're going to get into. So you're like, wait, so 5 to some power, 0.04, what? Okay, let's clean this up. This is why Harty always says he hates decimals. What if I look at 0.04 as a fraction instead? So let's do math enter and see if that makes this any easier. Okay, 1/25. Okay, so let's ponder this for a minute. I have to give you a couple of hints here. Okay. If I'm going to go from a whole number to a fraction, in other words, if I'm going to flip it. -2. Nice. Okay. Now, here's how he did that. Okay. If you have a fraction flip, it goes from a whole number to a fraction. Okay. That's going to mean you're going to have a negative exponent, because why? Negative exponents make us flip it. Okay, let me try and explain. If I'm going from a whole number and I somehow want to make that number go to the denominator, I want to flip it. I want to use a negative. So let's say, let me get the calculator out of the way. Okay, so if I had 5 to the -1, okay, I'd flip the 5 down to the denominator. So 5 to the negative first, it'd be 1/5. But I don't want 1/5. I want 1/25. So 5 to what power gets me to 25?
Wait, no.
2. Okay, so 5 squared gets me the 25 part. Okay. But I want the 25 down below. I need to flip it. How do I flip it? I make the 2 negative. Because then I have to flip my 5 squared. And 1/5 squared is 1/25. So anytime you go from, well, we're going to get to see it again on the next one, from a whole number to a fraction, or a fraction to a whole number, we've got to use a negative exponent. But we're going to get to see another one here in number 10 to try and make it come together a little bit better.
Do we have to do a fraction? Because I just typed in a calculator again.
You can play around if you want to with it. Yep, that absolutely would work. So just the same way we do it on number 10. Okay, if I have 1/2 to some power equals 8, okay, fraction to whole number, still got to flip it. So I know for sure it's a negative. 2 to what power gets me to 8? 3. And like Megan mentioned a minute ago, you can, if you want to. Okay, sometimes it may drive you crazy because you might have to guess for a while. But maybe you're like, you know what, I'm just going to kind of guess at this. I know it's a negative because I got this, but maybe I just start messing around. Oops, I didn't even put the exponent in. That was kind of bad, wasn't it? Bless you. So you go and you're like, nope, that's 4. That's not big enough. I got to do it. So if you want to play around on the calculator until you find a value that works, that's fine. Okay? What's that? Okay, we're getting there. Okay? But again, that's just one of my clues. If we go from whole number to fraction, fraction to whole number, we got to have a negative exponent. And then I got to throw in the really crazy one. Like, oh. You're like, wait, 9 to the x equals 3? What? Let's think about this for a second. Besides just dividing by 3, what's something else I can do to 9 to get there? Let's see here. Squaring it, no, that makes it get bigger. Would you agree? I heard it in the back. Would you agree that the square root of 9 equals 3? Yes. You're like, but that doesn't help me. I need an exponent. How do I write the square root of something as an exponent? I go, its exponent, which we always assume it's a 1, over the little number root, which it's a square root we assume is 2. Okay. So if it goes from a bigger number to a smaller, but not a fraction, okay, I'm going to have a square root of some sort probably. Maybe even a cubed root, but probably not going to go that far. But I'll tell you right now, most of the ones that you're going to deal with are going to be a lot more like number 8 was. But I have to show you the other ones because occasionally they may show up. So we got to be prepared for the emergency, but we don't necessarily going to be dealing with it all the time. Okay? And we'll see some more of those as we get a little bit further down here. Now we get to an easy part. We get to just go calculator, brain dead here for a minute. Okay? So when we get down here, we're just going to type this in the calculator and get a value. Okay? Now the only way I can do this is if there's no little base number down here, and we'll talk about that when we get a little closer. Typically we take these to the nearest thousandth. We're going to go to 3 decimal places. But when we get down here, we're just going to plug them in the calculator. So I get my log going. And you're like, well, what? Okay, I see it for log. What's that crazy thing you got after that? What's this ln thing? It's called a natural logarithm, but they put ln instead of nl. Okay, and it works similarly to a log does. It's just a slightly different value. So that ln button is just below log. Works the same way. I still can just plug it in the calculator. Not a biggie. And I get that whole line. And again, there's going to be a whole lot of ways as we move forward to be able to take advantage of the calculator or changing the way something looks to make it a little bit easier for us to find an answer. Okay. So again, nothing too shabby going on. I'm going to go past the science connection for right now because I want to keep life straight and to the point today with what we're doing so we don't go into a crazy overdramatic mode here. So, okay, we're going to come down to inverses. Now, inverses are fun once you get them. So here's how this works. There's 2 situations we can run into with inverses. Okay, the first one. A base and its log, which mathematicians like to call the of number. I'll explain that in a minute.
Wait, which problem are we on?
We're going to do 17.
Are we going to do 16 or no?
Probably not. So if you need to take up a little space to write this, that's quite all right. Okay, so here's what I mean by a base and its log of number cancel if they're the same. In number 17, I've got log base 6 of 6. Okay, what you're going to find out later is if that was my whole problem, the answer would be 1 because I'd end up taking the log of 6 divided by the log of 6, which is 1. So whenever we see a situation like that arise or occur, those 2 guys cancel and just leave me whatever's left up in the exponent. And that's true whether it's the log and then the number or the number and then the log. It still works that way. They're opposites. They're inverses. They cancel and just leave you with whatever values up there. And that comes in real handy when you're trying to solve equations. So that's kind of slick. And again, it's something that's new. We're going to have to get used to it a little bit before we feel real comfortable with it. So then you get to 19. You're like, what? Okay. Actually, that's our second inverse. And there's only two. E and natural log are opposites. They're inverses. They cancel, which I guess I should be putting in quotes because... So the E and the ln take care of each other and just leave me with the 15. Okay. Now, on 20 I'm going to give you a heads up. 20, I'm giving you a small preview of something that's coming down the road. You're not going to be expected to know this right now. Here's what we're going to do. Because for me to be able to cancel the E and the ln, that 2 can't be in my way. Okay? There's going to be this thing coming, okay, called condensing, where we squish them, where this 2 is going to swing up here and become an exponent. It's going to look like this. But again, you're not expected to know this right now. It looks really weird. You're like, wait, so I have an exponent and then I have an exponent on the exponent. Yes.
So the E and the ln cancel?
They do. And what's 3 squared equal? 9. Okay. And here's the slick thing. You could even type that one in your calculator if you wanted to, and you'd get the answer out. Kind of slick. So here, you're like, how would I do that? Well, if I wanted to do that on the calculator sometime, and I could, I hit second and ln to get E. Now notice it always already puts it in the exponent form for me. That's nice. And then I just do 2 natural log of 3. And I'd hit that. There's my 9. So that, I mean, all of these have ways to do them on the calculator, but you've got to understand where it's coming from to know sometime if you get a goofy answer, if it really is goofy. So as you're doing these, again, the ln and the E are opposites. And it becomes 5 times 3, not 5 to the 3rd power, because notice the exponent here is over with my E, it's not on the 5. So when it wipes it out, it just kind of bumps it down from being an exponent. But then you kind of start looking, and you're like, okay, just as I'm starting to feel like I get this, wait, 10 log 2, but wait, the 10 and the 2 don't cancel. That's true. But let's come back down for just a second. Okay. This thing called a common logarithm. You know, like when we have an exponent, we assume it's 1, and when we have a square root, we assume the little root number's 2. With logarithms, if we don't see a little number down here for my base, we assume it's a 10. That's where this whole thing of base 10 comes from. So let's rewrite this. Okay, if I actually put the number in, that's what it would look like. And now it makes more sense, because now it's like number 18 was. 10 and log 10 cancel out and just leave me with 2. Okay. And before we head to the back, I've got one more little introductory thing we're going to do. Just like number 20 was kind of a look ahead, 23 is going to be a look ahead as well. Because you're like, patience. I want to be able to cancel these, right? But I can't cancel 3 and 9. They're not the same. So here's what we're going to do. We're going to do something called a change of base. So let's think about this for a minute. Can I turn 9 into something that's 3 to some power that's equal to 9? 2, because 3 to the 2nd power equals 9. I haven't changed the value of my problem, because 3 squared is 9. But here's what I have done. The log 3 and the 3 can cancel. And just leave me what's left. It does feel that way sometimes. And actually, if you get yourself enough of a skill set, a lot of the time you can. Okay? Now, we are not going to do all of the back today to get some of you to relax. Okay? We're going to do the inverses section as we flip over, and then we're going to hold off on the graphing part until tomorrow. So, as we head to the back, Okay, finding inverses. We've done this before. We haven't done it with logs, but we've done it before. So just like always, when we're doing an inverse, I'm going to switch the x and y. I'm going to swap them. And I'm going to solve for y. So, again, it's a process. Step 1. Swap the x and y. So x goes in the y slot, y goes in the x slot. And now I got to get y by itself, but I have a problem. I have a log base 3 there, and no, you cannot just divide by log 3. Close. Here comes our big word of the day. Okay, we're going to, so let's see, to get rid of that log, whoops, probably it'd help if I actually was on the screen. I have to use its base to get rid of it. So the word of the day is exponentiate. Here's what that means. Exponentiate starts with the word exponent. I'm going to take both sides. I'm going to turn my sides into exponents. Exponentiate to get the 3 in the log base 3 out of there. So my answer would be 3 to the x power would be my inverse. Because again, it's exponentiate means they're exponents now. It's not 3 times x. It's 3 to the x power. So whenever I'm doing these, so I'm like, okay, x equals log y. And I'm looking at that for a minute. I'm like, okay, I got to get rid of the log. Well, wait a minute. We used a number a minute ago. I can't use 3 again. There's no 3 there. Yeah, remember, that's base 10 if I don't see a number. So I just use the 10 to exponentiate. Now again, keep these words straight. It is not exfoliate. We are not working with our skin. We are exponentiating. We are helping our mathematical health. So you're like, okay, this might not be the worst thing that's ever happened to me. So I get here to the end. Okay, now, what's my opposite of ln of a natural log? E. Still exponentiating. This time I have one extra step and I'll be there. Because y is not by itself yet. Subtract 1. Now here's the kicker. The 1's not in the exponent. Okay, so y is going to be e to the x power minus 1. Okay, not in the exponent though. Okay. So here's how we're going to tackle this. Tomorrow we will finish this note sheet, okay, with doing some graphing. There will be a worksheet that goes with it. However, let's hope Harty's head dunking has done some good. These problems on the front just go over the things that we did today. There's no graphing within it. So try some of these out. Again, it goes over a couple of pages. If need be, grab the book and just take a picture of 456 and 457. There will be time in class tomorrow to work some, but like I said, if you don't take this in chunks, if you try to stuff the whole steak in your mouth at once, it's all going to come out and you're not going to remember anything. So just get that down, do a little bit with it, tackle graphing tomorrow.